In this video, we're going to look at trig functions. Sometimes we call them periodic functions. Periodic because they keep on repeating. They've got a tendency of repeating themselves. For instance, you can have a function like this one doing this and going that, and then it may repeat the same thing again like that and like that and like that again. So they are periodic functions. They have a tendency of repeating themselves. Now, some of the functions that we dealt with in grade 10 were the sine function, the cosine function, and the tan function. In this page, we are going to look at the sine function and the cosine function, which we dealt with last year in grade 10. To be able to understand this graph, some people use a unit circle. So unit circle is like this with the coordinates 1 is to 0, 0 is to 1, minus 1 is to 0, 0 is to minus 1. So for the sine function, we'll just use the y values to plot the points. So for the sine function, which means that the sine of 0 is just 0. So we'll have a point there. The sine of 90 is 1. Sine of 90 equal 1. The sine of 180, it's 0. It's 0 there. And sine of 270 is minus 1. It's minus 1 somewhere over there. And the sine of 360 is again at 0 over there. So if I were to draw this graph, the graph of y is equal to sine x, so the graph will be just like this, and doing like that, and like that. So from here, there are things that we can find out, that we can fill in. Let's look at another one now. The graph of y is equal to cos x. Now to draw the graph of cos x, we are going to use the x values. So for x value here, so which means at 0, the graph is at 1. At 0, the graph is at 1. And then at 90 degrees, the graph is at 0. So the graph is just there. And then at 180 degrees, the graph is at minus 1. It is at minus 1. And then at 270, the graph is at 0. It's at 0. And then at 360, the graph is back at 1. 360 graph is back at 1. So if we are to draw this graph, the graph will look something like this. And turning there, there's a turning point. The x-intercept up to there. So the graph looks something like that. So there are many things that we can fill in here. We can see the shapes look similar, but they're not exactly the same graphs. Now, there are things that we need to look at again when looking at this graph. There are transformations that we've dealt with previously. We said if I've got a graph of y is equal to sine x, we can transform this graph and say y is equal to sine x plus 1. In the previous lesson, we say if it's sine x plus 1, it means that every point of this graph has been shifted 1 unit up. So to draw this graph, on the graph of sine x, I'll just shift it 1 unit up. So this point will shift 1 unit up. So I'll have a new point over there now. So this will shift 1 unit up. So it shift over there. This one will shift 1 unit up. It will be there. And this one will be there. And this one will be there. That will be shifting the graph by 1 unit. Let's look at the shape. So the shape will still be that. And then to touch there. And then touch there. And then I've got that one. Now, let's look at this one. This one we haven't done it. We did not do it in the previous lesson. So this is 2 cos x. The 2 here is multiplying the cos x. So we say here the graph will have a vertical stretch. You'll see when we do the things. In fact here, whatever value of y we're having, we're multiplying by 2. Now we said here the y value is 1. So we multiply that y value by 2, so 1 times 2 will give us a 2. The y value here is 0. So if you multiply 0 by 2, I'll still get that point here. The y value here is minus 1. So multiply this by 2, I get a minus 2 over there. The y value there is 0. I multiply it by 2, I get the same point there. The y value there is 1. I multiply it by 2, I get it there. It seems as if the graph now is having a shape like this, going down to 10 again, and then goes smoothly up and then to that point over there. So which means that the graph now has been, the green graph has been like stretched. That's a vertical stretch that I was talking about in the previous lesson. And therefore we can try now and fill up this table and answer the questions. So to answer the questions, there are terms that you need to know, understand them: amplitude, period, domain, and range. Amplitude, period, domain, and range. What is the amplitude? For this green graph, let's look at the green graph. The amplitude is just the height the graph is reaching if it is in a standard form. But to work out the amplitude of the graph is just taking the maximum height there and then add it to the height here and divide it by 2. That will give you the amplitude. In this case, to make things easier, the amplitude is just that distance over there from the rest position, which is 1. So if I were to take the amplitude for this one here, the amplitude, the rest position of the red graph is now there, over there. So it means that this part here is the same as that part there. So that distance over there is your amplitude, as was that distance there was the amplitude. So the amplitude there is that amplitude there. What is the amplitude, that distance there? It's 1 unit. So still here the amplitude is 1 unit. Let's come to this one. What is the amplitude of the cos graph? The distance there is the rest position there. So that distance over there is same as that distance over there, same that distance over there. That's 1 unit. So the amplitude is 1. What about this red one here? What's the amplitude for the red graph here? Now the red graph goes like that. So there is the the resting position of this graph. So the amplitude is that distance over there, which is same as that distance over there. How many units there? That's 2. It seems as if the number there helps us to get the amplitude of the graph. Okay, so if I say, for instance, we had to draw the graph of y is equals to -4, say, cos x. The amplitude, note, amplitude is the distance, it's the distance. So the amplitude for this graph here, the amplitude will be a 4, although I've got a -4 there in front. Okay, now let's continue. The period, what is the period? We start again with the green graph. There is a green graph. The period is how long is one wavelength. So this is like a wavelength. So how long is it from there to there? So from the start to the finish, that's 360. So that is 360 degrees, right? So what about this one here? What is the period of this one? How long is this one wave? It's again 360 degrees. It's 360 degrees. Can come to this one. How long is this graph here? What is the period of this green graph? Again, it's from there to there is 360 degrees. And this one here, the red one here, how long is this red graph here? How long is it? Again, it's 360 degrees. It's so easy. What about the domain? The domain are the x values of the graph that the graph can take. If you look at this green graph here, it can take all the x values starting from 0 to 360 degrees. Therefore, we say that the domain is an x values. X is an element of 0 until we stop at 360 degrees. Let's look at the red one. What is the domain? The x values this red graph can take from 0 to 360 degrees. So x is an element of, starting at 0, we end up at 360 degrees. Let's take at this one here, the bottom here. What's the domain of this cos graph? Again, it starts to take all the x values to 360. So x is an element of, starting at 0 degrees, then to 360 degrees. Similarly, with this one here, starting from 0 to 360 degrees. So x is an element of, starting 0 degrees, end up at 360 degrees, like that. What about the range? The range are the y values the graph can take. Let's take the green graph. This green graph is between -1 and a +1 there. So -1 to a +1 on top there. So the range of this graph are all the y values starting from -1, we stop at 1. Let's take the next one here. What is the range of this one here? So the red one. Now this red one, it takes from 0 to 2. So the range for this one is y is an element of starting from 0 until we get at 2. Take this green graph here, y is equals to cos x. The green graph is between -1 and 1. So y is an element of -1 and 1. Let's take this red one now. It's from -2 to 2. So y is an element of -2 to 2. So that is the sine and the cosine graph. Let's look at the tan graph. The tan graph also uses the unit circle, but in the unit circle now, instead of using x or y, we use both x and y. In that case, how we find it, we divide the values. So how do you divide them? This the y value divided by the x value. Okay, now let's see what we can get when we plot the points here. Let's plot the points. So at 0 degrees, what is 0 divided by 1? That's 0. This is 45. What is square root of 2 over 2 divided square root of 2 over 2? That is 1. So at 45, there's 90 there. There's 45 is here, so I've got there. At 90, what is 1 divided by 0? That is undefined. So what does that mean? When it's undefined, then I've got a vertical asymptote. I can draw my vertical asymptote here going like so. So I've got a vertical asymptote going down like that. All right. Now the next one. So what about at this point over here? So I'll divide this with this. What answer am I getting? It's a -1. So at 135, I get a -1 point. Now what about at 180 degrees? At 180 degrees, I divide again the 0 divided by -1, I get 0. So I've got a point there. What about at 225? That's 225. I divide these two numbers. What do I get? Both x and y are negative, you can see here. So then I get a positive answer. So there is my answer. What about at 270? So y value divided by that is undefined. Again, I get an asymptote. And then if I continue again, now I'll move on to 315. At 315, I divide this and this. What answer am I getting? I'm getting a negative answer, -1. So it's -1 over there. What about when I reach 360 degrees? Again, I get this divided by this, I get a 0. If I were to draw this graph here, you see that your graph goes up like this and comes something like this, and then it goes like this. If I were to continue, it will do the same thing and the same thing. So it's periodic, it repeats itself. And therefore, now let's try and answer the questions for this graph here. What is the amplitude of this graph? How high is this graph? So this is the amplitude of this thing here. The amplitude of this thing is going up, up, up. So the amplitude, you can say, is undefined. Okay, what about the period? The period is the length of one wavelength. So this is a piece. That means that there's another piece here. So if we take this one here, it gives us a full piece from 90 to 270. How long is that? Is 180 degrees. So that's 180 degrees. What about the domain? The domain of this graph. The domain are the x values this graph can take. It is taking all the x values from 0 to 360 degrees. But it's got asymptotes we've got there. So the domain are all the x values from 0 to 360. So we can say, so x is an element of 0 degrees to 360 degrees, but x cannot be 90 degrees or 270 degrees. Why? Because there we've got asymptotes. What about the range? The range is what y value is this graph taking. It's going all the way to infinite, even downwards to infinite. So the range is that y is an element of negative infinity to positive infinite. Let's look now at this graph here we have to draw. What does this mean? If that's the tan graph, what does the negative sign in front of the tan graph mean? Remember from the previous lesson when we were talking about transformation of functions, I mean the negative there, it means that we are reflecting the graph about the x-axis. So we'll take this graph and we'll turn it around about the x-axis, which means that this point now will be there. So this graph of mine will be doing something like this. And now if I turn this around, so this point will be up there and this one will be down here, so which means that now my graph will be doing something like this, and then now on this side this one will be there, so which means that my graph will be doing something like this. So that's it. So now let's try and fill this. What is the amplitude of this graph? Again, the amplitude is undefined. We don't know it. It's undefined. What about the period? How long is this? This is 180 degrees. And then what about the domain? The domain is the same as the green one. It can't be 90, it can't be 270. So x is an element of starting from 0 degrees to 360 degrees. However, x cannot be equal to 90 degrees. Also, it cannot be equal to 270 degrees. What about the range? The red graph goes up to positive infinite or down to negative infinite. So y is an element of negative infinite to positive infinite. That is as easy as that. Note the one thing that you may be asked here. Check that the period of this graph of the parent function 10x is 180 degrees, but here with both the sine graph and the cos graph, the period was 360 degrees. These will come handy when we are doing more of the trig functions and the equations. Remember that. Now, if you can try on your own these few problems from your textbook, which is Siavola Grade 11 Maths, Chapter 5, 5.5, the sine functions, exercise 5.20, numbers 1 and 2, 5.6, the cosine function, exercise 5.24, numbers 1 and 3, then the 5.7, we've got tangent functions, exercise 5.28, numbers 1 and 4. And that would be easy for you to comprehend.